All right, hello and welcome back. So this is the first video that I've made for quite some time, and thank you to the people who nudged me in that direction today, made some requests, and asked if I was going to be making videos again. So I will try to make videos more in the future. It does help me if you request which ALEKS topics to cover. I do really like making these ALEKS videos. I think that they're helpful and they should be helpful for years to come. So in any case, let's jump into this one. So as you can see here, I'm actually going to show three different examples. I've just rewritten the basic question from three different examples. This is the top one here. You can see is this question here for deciding the relative energy of electron subshells. So let's just jump into this one. The first thing that we're going to do actually though is we're going to talk about the periodic table. So to solve this topic, this deciding the relative energy of electron subshells, we really need to have something like this, or we really need to understand what's going on in this diagram, how I've labeled this periodic table. And this is, there's a lot of different ways to go about learning this or memorizing, certain things. To me, this is the way to do this. If you can understand and you can generate this, like you always have access to a periodic table, you can generate this diagram labeling, 1s, 2s, 3s, 3d, labeling all of this sort of stuff pretty easily, and it's pretty easy to remember. So when I created this, basically what I did is I started on the left-hand side, and I said, I know that we start with 1s. I think that's everyone can agree. We all know that we start with 1s. In terms of when we're talking about electron orbitals and atomic orbitals. We know that's the starting point, right? So if you start there, 1s, 2s, you're basically just counting down 1, 2, 3, 4, 5, 6, 7. We know that these are the s orbitals. The next thing I did was I came over here and I said, well, I know that this is the p block. When we're talking about the electron configuration of boron or carbon, of nitrogen, oxygen, we're going to be filling in the 2p orbitals. So this is the next thing that I'm going to label. And it's pretty easy. Like we know that there's, 3p orbitals. We know that this chunk represents where you could fill in 6 electrons, 2 electrons per orbital. So it's easy to remember that these are the p's, right? We've got 1s orbital, 2 electrons, so we've got 2 spaces. We've got 3p orbitals, therefore we've got 6 spaces. So, and in terms of the number, this one started at 1, this one starts at 2. So 2p, 3p, 4p, so on and so forth down. Now over here, next is D's, right? So we've covered this part, we've covered this part. What's in the middle? In the middle are the d orbitals, 5 d orbitals, and if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way across here. So that represents the 5d orbitals where we could put in 10 electrons. But in any case, in terms of labeling, we know, 1, 2, 3. So we're just counting down. And then now we've got all of our d orbitals. Lastly, the f orbitals, again, same thing. We know the number to start on because we just go through them. We start here, 1, 2, 3, 4. And then these are the f orbitals. Now I do want to point out that the f orbitals are actually plugged in right here. So unlike if we had a sort of a true periodic table that was showing everything all together, these 2 rows would actually be right here, and then all of this would sort of get pushed off. And I actually have seen periodic tables like that, posters and things like that, where these are actually inserted there. So I just want to point that out. We'll talk about that as we go through the video as well. Okay, so let's now put this into practice. So basically this is the starting point, and then I guess we should talk about how do we use this. So how we use this is basically we read, we create this and then we read left to right. So 1s would be the lowest, then 2s, then 2p, then 3s, 3p, 4s, 3d, 4p. And that's where we're going to start getting, weirdness going on with our numbering, is because, these numbers are sort of offset. Same thing when we get down to the f's. So right here, I could read across 6s, then would be 4f, right? So this goes down here, then 5d, then 6p. So, your numbering, it's all confusing unless you're just reading it off this table. And this is what I would recommend. So let's go ahead and do it. So the first one is 3p, 3d, 3s, 4s. We need to label or arrange these in order of increasing energy. So I'm just going to use our periodic table and sort of refer back to it. So here we've got our 3p, so that's up here. So we know that that's sort of that energy there. 3d is down here, so that's going to be a higher energy. And then 3s is up here, and then 4s is here. So when I'm ordering these, I'm just going to find which one is the highest up on the list and furthest to the left. That's going to be the one that has the lowest energy. So I know that 3s is going to be the lowest. Next, I'm just going to read left to right, would be 3p. So the next highest energy orbital from 3s is going to be 3p because it's the next one I run into. I'm just reading from left to right. That's the next one I run into. So that's going to be the next one here. So 3s, 3p. Now we're looking for 4s or 3d. So since I finished 3p, I just start back over here on the left-hand side, read from the left to the right. Next would be 4s, and then 3d. So that's the 4 orbitals that I had here, and then, or subshells, I guess I should say, and then I'm just going to order them here. Let's do the next one. 4d, 5s, 5p, 6s. So again, I'm going to go back to this. So maybe we'll put this up here like this. So 4d is here. 5s is here. So we know 5s is a lower energy than 4d. We're just reading left to right, top to bottom. 5p is here, and 6s is here. So again, for this line, it goes 5s, 4d, and 5p. So that's going to be our first one. So we'll go 5s, the thing at the top left, that's going to be the lowest energy. Next up from 5s is 4d, then 5p, and then lastly 6s. Great. And then I've got one more that includes the F orbitals because we definitely want to have an example that looks at those. So 4d right here in the middle, 6s over here, 4f. So 4f, remember, these go in right here, right? So these two rows go in right here. So 6s, then it would be 4f. Then we've got 5p. So 5p is up here. So looks like we've got, just want to make sure we do this right. So 4d is going to be first, right? So 4d out of these 4d is the one that's furthest up and, most to the left. So that's going to be where our starting point, 4d, then we've got 5p, then we've got 6s, and then we've got our 4f here, which is weird, right? Like, it's weird to say that the 4f is a higher energy than the 6s, right? But that is, that's how it works. That's the F orbitals are going to be higher energy. So 6s, next would be 4f, then 5d, then 6p. So as we're going down, we're increasing in energy. As we're going left to right, we're increasing in energy. And I did want to point out one last thing. All of the examples that I saw, this said increasing energy, but definitely be careful if this says decreasing energy. There might be some cases like that out there. All right, well, hopefully that's helpful. And thank you again for the request. And I'll try to make this a more regular thing. All right, cheers.